Welcome back to JEE Blunders, where you learn the don'ts first. So, what do we have today? Find the capacitance of the following arrangement. So, we have a parallel plate capacitor. These are the two plates, and the spacing between the plates is D, and the area of the cross section of the plates is A. And I have four pieces of dielectric with dielectric constants as shown here. So, I have four pieces of dielectric placed in between the two plates. Let's say the thickness of the dielectric, or the thickness of all four of the dielectrics, is D by 2. The thickness of all four of the dielectrics, or sorry, the area of cross section of the dielectrics is A by 2. So we have to find the capacitance of this arrangement. So one way that I can think of is to break down this problem into smaller problems. So let's try that out. I have the same, well, I can rewrite this problem in a slightly simplified manner. So now I have two capacitors. This is K1. Let me just use the same color. This is K1 and this is K2. And similarly, I have these two dielectrics over here, K1 and K2. Now, so I've rewritten this problem as follows, and I can do that, right? Because these, it's as if this is one capacitor and this is another capacitor, and these two are in parallel, correct? So I can further break this problem down. So let's see. This can be rewritten as, so I had one capacitor, now I've made that into two, and now I'm going to make that into four. Right? Because these two dielectrics, these two capacitors, or well, this thing can be written as two capacitors in series, right? So this is K1 again, this is also K1, and this is K2. Alright, so now this is a straightforward problem, right? We have four capacitors. Each of this has a cross section of A by 2, right? A by 2, and a spacing between the plates of D by 2. So actually I'm going to um, in order to simplify our final expression, I'm going to assign some new variables. Let's call C1 the capacitor, the capacitance of this capacitor, and that is A, A being the area of the capacitors. So A by 2 epsilon naught by the spacing of the plates, D by 2, times the dielectric constant. So C1 is K1 times A epsilon naught by D. Sorry about that. Similarly, C2, it's the exact same thing, right? Except we have K2 instead of K1. So C2 is K2 times A epsilon naught by D. So what is the capacitance of this arrangement? Well, we have two capacitors in series. So the capacitance of this part would be two capacitance in series, right? So it's C1 C2 by C1 plus C2. And the same goes for this one as well. It's the exact same. And now these two are in parallel, so we can just add them up. So the effective capacitance would be the sum of twice this, right? So it's 2C1 C2 by C1 plus C2. And this seems to be our answer, but wait, there is one more way I could have done this by. Why did I have to divide the capacitor along this axis? I could have done the same along this axis, right? So let's see, it should give us the same answer. I'm going to break down the single capacitor into two capacitors first. Oh well, sorry. I'll break it down into two capacitors, correct? Now I have those four dielectrics, K1 here, right? So now I've assumed that this part is in series with this part, correct? And that seems reasonable. Now we can break this down further into four capacitors like we did previously. So these two are in parallel now. Oh, I mean, yeah, they are in parallel. So this is one capacitor, and now this whole thing is in series with this, where these two are in parallel now, correct? So now I have K1 here, K1 here, K2 here, and K2 here. Now, once again, we have two capacitors in series. Just like in the previous scenario, this is again the capacitance of this is C1, this is C2, and so this would be C2 and C1. Now these two are in series, correct? So the effective capacitance of this part alone is C1 plus C2. And this is again in series with a similar capacitor because the effective capacitance of this part is C1 plus C2. Now we have two capacitors in series. So we can use our expression C effective is C1 C2, where C of the first capacitor times C of the second capacitor. So that's C1 plus C2 whole squared by the sum of the capacitances. The sum of these is 2 times C1 plus C2. So this cancels out. So we get that C effective is C1 plus C2 by 2. Wait a minute. We got a different expression initially, right? Why is it that we're getting a new expression now? I mean, both of these make logical sense. Well, I can't think of the solution to this mystery, but if you do, please let me know in the comments below. See you soon.